Hi Edgar. So there's not a huge amount that is actually logs in this, um, but there's a key concept that I feel students muck up over and over again, and it's the idea that when you apply a power or, well, pretty much any function actually, but in particular power or a logarithm in this case, you have to apply it to the whole side, not the individual terms. So we apply this to each side of the equation. Now you might think, well, why is that different for multiplying? And it's actually quite a deep, pure maths terminology. Is that when you have multiplication, it's something called distributive. And it's this idea that if I had an equation that potentially looked like this, we just get, if I say I wanted to times everything by 2, we get in the process of doing this. And it looks like we've just times all the individual terms by 2. But really what has happened is that we have times the whole side by 2. And this property of distributive means that now when we expand the brackets, it's worth the same amount. Okay, so we maybe will fall into that trap with logarithms and exponential functions, because some students think, oh, I'm just going to raise this up as a power of 10 and cancel it out, and do the same with this, do the same with this, but it doesn't work that way. Now, how do we get round that? Well, the thing that we should be trying to do is we should always be trying to combine the logarithms together to make one single logarithm. And if we can do that, then it's easier to cancel out. So that's the process we want to follow with any kind of log equation, really, is we want to first try and simplify each side. To a single logarithm. Okay, now that's set up quite nicely, because we know that if we've got 2 logarithms added together and they're the same base, then we can multiply those 2 terms together. They're equivalent. And now we've got exactly what I wanted to happen. I can now raise these up as a power of 10, and they're going to cancel because it's the inverse function. Exponentials and logarithms are inverse of each other. So I get one equation, x times by y equals to 3. We don't actually need to do anything in terms of rearranging for the second one. We can simply just go and raise everything up as a power of the base, or as 10. So that's going to cancel on that side, but here I'm going to have 10 to the power of 1, which is 10. And hey presto, we get 2 simultaneous equations that now don't contain a logarithm. Let's label them 1 and 2. I think the easiest way is probably to rearrange this so that y is the subject. So I've got 10 minus 3x, and I'm going to sub that into equation 1. So I end up with x times this. Okay, I feel like you don't really need me to do the rest, but let's just plough through. So we get quadratic. Oh, fancy food. Yeah, plus 3 equals 0. That factorises to factorises to give me that. So my x values are 1/3 or 3, and I can substitute that back into So sub into y equals 10 minus 3x. So when we do a third, so x equals a third, y is going to be equal to 9, and x equals 3, we'll get y equals 1. Okay, but if there's one thing you want to take away from that, it is this idea that you have to apply a logarithm or an exponential or any kind of power to the whole side of the equation. So simplifying down first, that should be the first thing that you're trying to do. All right, keep up the hard work, and yeah, let me know if there's anything else.